Hi, let's talk about VLANs. This is a lecture on Chapter 6, topic of VLANs. We've used them, or at least we've had to assign IP addresses to them to get access to switches. Let's see what other uses VLANs could have. So we're going to look at how I can talk about the purpose of it, talk about how a switch forwards frames based on the VLAN configuration, some different way to implement it, how to configure a switch port assigned to a VLAN, how to configure a trunk port, how to troubleshoot some of that stuff. And then look at how do I do inter-VLAN routing. And one of the things that you'll probably, if you go into the CCENT exam and stuff, you're probably going to get something called router on a stick. So how do I use inter-VLAN routing to pretty much have multiple VLANs have one switch, one output to a router. So talk about some of that stuff today. So let's look at the segmentation. Now, VLAN, when I'm defining a VLAN, you like to separate it to say where is basic traffic is flowing. Now, you can do it any way you want. In this example, you're seeing, even though they're on multiple floors, I may not want, maybe I got IT on all 4 floors, or 3 floors in this case, but I don't want to have HR and sales interacting with me, so I want to be able to isolate the traffic between all IT on the same network. So you're seeing the same network traffic. Each one, you got 3 different routes. 3 different IP addresses or network addresses. And now we've created 3 separate VLANs so that the switches, because what happens if I let the network address make that determination as far as routing traffic? So if I want to talk from floor 1 to floor 3, what has to happen? I got to send my packet all the way back out to the router, which then routes it back to the appropriate switch. But if I can isolate traffic a little bit differently, maybe I can do something slightly different. So a VLAN allows us to segment our network based on different functions, different factors, whether it's a function, whether it's product team application, with really no regard to any physical locations. You're allowed to implement access and security policies that you normally can't do on a router. It allows me to do a logical basically partition that layer 2 network, that switch layer. So it can have multiple, so by allowing me to partition that switch allows me to have multiple VLANs on the same switch exist, but not allow me to communicate between them unless I go out to the router. Now, each VLAN is its own broadcast domain, and of course it's usually within its own IP network. They're mutually isolated. Packets can only pass between them, between routers. So if I'm going from VLAN 1 to VLAN 2, I've got to go through the router. So it basically says this partitioning of the network takes place only inside the layer 2 device. In most of our cases, it's usually a switch. And hosts that get plugged into it have no clue that the VLAN exists and they're being isolated from other ports on that switch. So some of the benefits of VLAN, and here you see a small network, only one router. This probably would be close to what we kind of have at school here. I've got one router to the outside world, but we've probably got close to 40-some switches connecting every device, every computer in the system. So having VLANs in each one would allow me to, I could go ahead and set up, different switches for each classroom. I could set up different security on each, network. But why? So by setting up VLANs, I can improve the security so that people can't just plug their port into different access point, network interfaces. It can definitely reduce the cost of my network only because I don't have to go out and buy a bunch of routers. I can keep it all, I can kind of get security in place without having the router do all that work. I get a little bit of performance in it. Definitely have reduced the size of my broadcast domain, because what happened with a switch? Every single port was in the same broadcast domain. So if I had a packet that didn't have a MAC address, it went to every port. Well, now I only go to the ports within that VLAN. So I get a little bit more IT efficiency, management efficiency. Excuse me. And I get a little bit easier to manage my projects and applications going through. So there's a lot of other aspects reasons why you want to use a VLAN. Now, there are different types of VLAN. You got data VLANs, which basically just user-generated traffic. Default VLAN, when you first brought your switch up, you had a default VLAN associated with that whole entire switch. And it was basically what? It was used for everything. It was probably set to be VLAN 0. One of the first security things we did was what? Change that VLAN port from 0 to 99 or some other number. So if somebody did get the IP address of that switch, you end up having some way of securing it. The term native VLAN is basically to use anything that's not tagged, anything that's not going to a specific purpose. It stays along native VLAN. And then you got the management VLAN, which then says, how do I manage the access of data? So if I show, again, examples of the type, when you do a show VLAN brief, you get what? You get the name, and right now VLAN 1 is the default. And as you can tell here, every single port is associated with that VLAN 1. So all ports are by default assigned VLAN 1. The native VLAN is VLAN 1 by default. Now, granted, you can change it. And also the management VLAN is set up to VLAN 1. So that would tell me that I don't want to stay on VLAN 1 very long if I put it in a new switch. So one of the first things you're going to learn is, how do I change that? So, same thing with voice over IP. You can have, switch configured support voice traffic uses VLAN 150. So it basically says, hey, I got to have a switch port configured for voice traffic that allows me to use that VLAN. So but keep in mind, by having a different VLAN, I can now prioritize my voice traffic at a higher priority, so it gets better response all the way through the router, so that voice traffic or video traffic or whatever traffic you want, you can set priority to that port number. Now, because voice over IP traffic is usually time sensitive, you want to make sure the bandwidth's there to make sure you got voice quality. Even though we don't need a lot of bandwidth, you still want to make sure that you can be heard. So you can give it priority over different types of network traffic, over raw data stuff. Because remember, we'll come back to that later. The ability to route over congested areas if you need to, because you got to remember that voice traffic, you want to minimize that delay, because you don't want to hear echoing. You don't want to say, okay, wait, can you hear me now type stuff going on. So you want to make sure because voice over IP traffic is time sensitive, you want to minimize that delay as much as possible. Voice VLAN features just allows us to carry voice traffic over any IP phone. Now, the question then becomes, what happens when I got a multi-switched environment? And here you got 3 switches and different VLANs, different network addresses. You got a management, so somebody securely changed my security from VLAN 1 to VLAN 99 to make it a secure network. And now I'm going to, we want to configure the traffic, what traffic can go between different, let me just slide this out of the way here a little bit. Which traffic can go between the different switches. So switches 1 and 2 and 1 and 3 could be configured to allow traffic to come through But if I didn't have a trunk to be able to connect those switches together, it would not allow traffic between VLANs. So my VLAN would stay pretty isolated. So I want to make sure I can be able to configure a trunk basically to handle more traffic, different features on that VLAN. So now, what is it? A VLAN trunk is basically a point-to-point link that carries more than one, because you're in a multi-switch, multi-VLAN environment like we got here. That trunk allows me to carry more than one VLAN. A VLAN trunk is established between switches, so that same VLAN, so that means if I got VLAN 10 on two different switches, they can communicate with each other. If I've got only VLAN on one switch but not on the other, it will not transport across that. So VLAN trunk, it's not associated with any VLANs, and neither, the trunk ports, you don't even have to have them established. So now Cisco supports the 802.1 Ch protocol for IEEE. It's very popular, and we'll get into that a little bit later. Now, how do I control segmentation? Because remember what happens if I don't segment, if I don't have VLANs, in a network like this, what happens? I mean, if I can't find something, it broadcasts what? To every single PC across the device. So, because that switch forwards that broadcast frame out. Well, what happens with VLANs, now when PC1 tries to send out a broadcast message, it only forwards out the broadcast to ports in the same VLAN. So even though there are VLANs 20 and this one's only got 10 and 20, this means only the faculty PCs will get receive the broadcast, but the student ones will not. Whereas in this case, I broadcast guests, students, faculty, they all go across and get routed out. So it allows me to basically start controlling these broadcast domains, which of course means what? There's less network traffic, a little better performance, so a good deal all around. So a VLAN can be used to limit the reach of broadcast frames. VLAN itself is a broadcast domain of its own. A broadcast frame, it's only forwarded within the VLAN only. And the VLAN can help control the broadcast frames and it's their impact on the network, less traffic and things like that. Unicast and multicast frames are forwarded with the originating VLAN, only within the originating VLAN. Now, in a multi-switched environment, sometimes you want to make sure you frame. So how do I know which VLAN a frame is in? Well, frame tagging is the process used to I insert the VLAN inside the header of the frame, and then it's used to transmit over the trunk link. Switches tag frames to identify the VLAN to which they belong. So you want to make sure when it switches, says, hey, ports 1, 2, and 3 are VLAN 10, where 5, 6, and 7 are VLAN 20. Those packets are framed with that VLAN that it's going to, so that you won't get multiple VLANs on it. They only have the one that originated the thing. Now, you got different tag protocols exist, but the 802.1 Ch is probably the most popular. The protocol that defines the structure of the tagging can be added to that frame. So once I understand that tagging, I can make sure I put insert in the frame. And switches add those tags. My picture's always in the way here, isn't it? I'm not sure you can see it down there. The switches add the tags to the frames before placing them into the trunk link. So just before they get to the trunk link, that's when the tags are added. And of course, they remove the tags, before they start trying to broadcast them out to non-trunk ports. So it's that trunk port that says I'm adding the tag, removing the tag. So when we've done it right, the frames can go across many different switches via the trunk links and still be forwarded to the correct VLAN. So it's just a very easy way to insert. So here's just a graphical fields as far as the 8021Q frame is, because we've got our normal frame. You got destination, source, MAC, the type and length. Well, in this case, we got a type. What's my type here? I'm going to insert a tag right in the middle here, and in that tag, it's going to give me a type of tag, and then some options I've got here, whether I can give it a priority, what kind of things can I do with this packet. So just know that native VLANs and tagging. Now, the native VLANs are control traffic that are sent on the native VLAN. Now, what we said earlier said the default VLAN, native VLAN was 1. But it control traffics you don't want to tag, because you don't want to forward it to every single switch out there, right? So frames you've seen in untagged remained untagged, and replaced. So I'm trying to send control only that way. So I'm not going to redirect it to a particular VLAN. I'm going to send it off to all ports. If there are no ports associated with that native VLAN, then no other trunk frames, and the frame, as with most destinations, end up getting dropped. When we configure a switch port, configures it, they don't send tags on the native VLAN. So Cisco by default VLAN 1 is that native VLAN setup. So the question is how do I tag a voice VLAN? So let's just take an example here. Here you've got voice over IP, you got a certain interface. I'm going to configure this tag voice over VLAN 150. So here I've got show interfaces and the port I'm looking at the switch port capabilities here, because that gives me a whole lot more information. It gives me what my VLAN access is. It now says it's a student port. And it's a voice. So I've got an access VLAN and I've got the voice VLAN set up. Now, I think this is one of the activities you can do online, showing you what type of, how a frame goes between PC1. When PC1 sends out a broadcast, what do you think happens? PC1 sends a broadcast, it doesn't go to 2, doesn't go to 3. If I got trunk port set up, it's going to go and only hit PC4. If I do PC2, you're going to see what? PC5 is the only one, because that's the only one on VLAN 2. And the same thing for PC3, because again, it's being VLAN specific. So how do we go ahead about implementing this? Now, know that we've got data ranges, some of the switches based on which we can have over 4,000 switches. There's usually 2 different categories. There's normal range and extended range. Normal range between 1 and 1,005. The configuration is stored in the VLAN.dat file, but 1,002 to 1,005 are reserved. So when you do that first show VLAN, you notice those 4 ports are there and nothing are done. Now, extended VLAN range go from 1,006 to 4096. Now, those configurations are stored in the running configuration. So now notice the different location. VLAN 1 to 1,005 are stored in the VLAN.dat file. Anything above that gets stored in non-volatile RAM. And then also the VLAN trunking protocol, VTP, does not learn about extended protocols, extended VLANs. So there's some differences as to where they're stored and who learns about them and who doesn't. And as an administrator, you're going to have to decide, do I need to make sure that this VLAN trunking protocol knows about these VLANs or not? So here's an example of show VLAN brief, normal ranges, default VLAN 1, and here's the ones that are isolated, protected already. Now, if I want to create a VLAN, configure terminal, VLAN, give it a name, give it an ID, a numeric value, in this case VLAN 20. This is what the example here, give it a name so it's when you're reading things it's a little easier to understand, and you get out of the configuration mode. So configure terminal, VLAN 20, give it a name, and exit. So that way everything, that now means anything on that port belongs to that VLAN, and if there's no other VLANs on any other ports, that's the only person that can talk to that. Now, how do I assign ports to VLANs? So first thing I had to do is I had to create the VLAN. Whoop, wrong direction. So I had to create the VLAN. So I had to make sure the VLAN had a name. Now, you didn't see anything about assigning it to an interface. You just gave it a name. You gave it some general information. Now, if I want to assign ports to a VLAN, now I got to go to the interface level. So I go to interface, whatever that name is. Now it's switch port. So now it's like I'm doing security here. I got switch port mode. I'm saying I'm going to change the mode. I'm going to change it to access. Whoop, whoop, whoop. There it is. To access. And I want to access the VLAN, and which VLAN do I want to access? Well, which one did we create? We created number 20. So in this case, I've got which interface, switch port mode access VLAN 20, and now I've assigned VLAN 20 to port F0/18. Now, here's just another example. VLAN 20, give it a name. Whoops, now what do I got here? I've now got a VLAN here. I've got a voice VName 1. So now I've got different ports. Interface, mode access, VLAN 1. And now I say, what kind of security do I want to give it? And now I can change the, what security do I want? What quality of service do I want? And then I assign that port to voice over IP interface. Now, what happens if I want to remove or change a port member? So one, I can totally remove a VLAN assignment to a particular interface is no switch port access VLAN. So that's net no does that same thing. But if we had done a show VLAN brief when we added F018 to this, you've seen, instead of active, you've seen active, and you would have actually seen a port number. So that tells me what? Even though I took the access, removed the VLAN assignment, it did not remove the VLAN. All it did was say, hey, the VLAN still exists, it's still in our database, but I've now reset VLAN 18, and 18, if any luck, should be sitting back over under the native VLAN. Now, how do I verify it? Show interfaces, switch port, and it should tell me what my mode is and what options are. So that's the way you're going to verify it. You better see it back on VLAN 1 or wherever you set that default VLAN to if you changed it for security purposes. Now, if I want to change the port membership, again, since VLAN 20 is, I just changed the interface, switch port mode access, changed the access, assigned it to VLAN 20, and we're done. Instead of 18, I've got 11. So the same thing you saw earlier. Now, what happens if I want to delete a VLAN? Well, you got to get in configuration mode and no VLAN 20. So, because how did we create a VLAN? Well, what did we do up here? We did a, back up here, it ended up being too far back. You just, when configuration mode, you went VLAN 20, created it. Well, how do we get rid of most commands? How do I turn off an interface? How do I, power it off, power it on? So if I want to remove a command, no space, VLAN 20, It's done, and now you see that's been deleted. Now, we can also delete the entire VLAN.dat file, and you've done that hopefully in NET125, probably one of the first lessons in trying to remove old information out of a switch. Deleting that flash:/VLAN.dat file can get rid of all that VLAN.dat, because remember, all those ports up to like 1006 are stored in VLAN.dat on the flash drive. So you want to make sure you get rid of that. So if you're don't want to put restrictions on your VLAN. So what kind of verification do I have? You have a show command, show VLAN brief. Basically just one line for VLAN, the name and which ports. You can specify the ID and the show me VLAN ID 20. It'll give you all the ports. Show me the name. Since I gave it an identifier and a name, I can display the name. So several different options. You can give me a summary information. So the show VLAN command shows a lot of information. Several different options of it. Pay attention. The same thing, you can do it on a per interface basis. I can do show interfaces VLAN and show me all that information. I can do it on a per port basis. So you've got several different options, whether on the interface side or on the VLAN side, based on what you're interested in. So here's just a couple examples. Here's a show VLAN name student. So I'm looking for VLAN 20 with that, and then it says, hey, which VLAN, what's this information? It tells you which ports are assigned. Is it active or not? Now, if you do, show interfaces, you can tell. I got a different format. Now I'm looking at, this says the VLAN, so everything's structured on a VLAN basis. How many VLANs are there? And this is on a per port basis. It tells you what information is available. So those are two different things. So now the question is, multi-switch, multi-VLAN, what do I have to do? I need to be able to configure a trunk, be able to have this access to track this VLAN between the different switches. So to do this, I got to do configure terminal interface, and I go to switch port mode. Now instead of access, it's trunk. So now I'm going to say, hey, what am I doing? I'm going to say, switch port trunk native. So I'm going to allow, specify the native VLAN for untagged frames. I'm going to say, hey, I'm going to allow switch port trunk allowed which VLANs can access or go through that trunk. So and then you list VLAN 20, VLAN 30 could be allowed. So here, let's look at an example here. Switch port mode trunk. I'm in the interface mode. I've changed my native VLAN to VLAN 99. So instead of VLAN 1, it's now 99. And I'm going to allow VLANs 10, 20, 30, and 99 to go across that trunk. If it's anything other than these, nothing goes across. So just a little bit of an example here. What can and can't go through. I'll let you go through that. Now, if I'm resetting the trunk to its default state, so basically what am I doing? I'm turning off, all VLANs. I'm turning off all the VLANs. I'm turning off, resetting the native VLAN just by the no switch port trunk allowed or trunk native. So that allows you to get back out of all that information. And here just shows you, did you do it correctly? Here's the commands you typed, and then what you're going to see. Back to VLAN 1, trunking. I pretty much allow all VLANs across the ports. And here you see it on interface F0. And here what happens if I, here you got static access. So it gives you different areas. And here I've changed VLAN switch port trunk. I've changed native. So here I've got, this says interface FA0 is a trunk port. Which protocol am I using, and what the native VLAN is, and that means native VLAN tagging is enabled. So you got to, all that stuff goes through. So what happens if I've got some troubleshooting issues? What happens? IP addressing issues. it's a common practice to associate a VLAN with a particular IP network. Because IP networks only communicate through a router, devices within a VLAN you don't want to go all the way to the router every single time. So you want to make sure that you can kind of reduce the amount of traffic on the VLAN. So this figure shows you PC1 can't communicate to the server. Why? Because here, I'm on what? I'm on VLAN 10. That's on VLAN 10. That's good. But I'm allowing 10, but I don't know what's allowed. So it has the wrong address. So what do I have here? I got can't connect to the server. But now how do I change my VLAN? So if I'm troubleshooting this, I want to verify what commands I got. No connection among device in the same VLAN. Is the port in the same VLAN? How can I tell? You can do the show VLAN or show MAC address table. Both of them are going to tell you are they associated with the right VLAN. If they aren't, put them in the right one. If they are, now you want to make sure is that VLAN present in the database. So just because I defined it, I mean, there's no error check that says just because I assigned a VLAN to a port doesn't mean it exists. But again, I show the show VLAN, interfaces, interport switch, those commands based on what level you're trying to troubleshoot it at. And make sure if it's not in the database, create the VLAN in the database. And if at both those places, so basically port assigned to the same VLAN, let's make sure the VLAN exists. And between those two, you should be golden. What happens if the VLAN that a port belongs to becomes, is deleted? Guess what? That big port becomes inactive. Because you're telling me that VLAN 10 is available, but if for some reason it goes away, I can't communicate. So just pay attention to when you show that MAC interface table. What happens if I'm troubleshooting the trunks to make sure that, so in this case, is a VLAN, native VLAN, do they match? Do the local and the peer ports, do they match? You got to be looking at the same VLAN. You don't have one at the other. Two, trunk modes. I got to make sure that both the local and the peer ports are compatible. Are they both defined to be trunk ports? So and the way I can tell is that you show interfaces trunk, and it should tell me which interfaces are trunks or not. They have to match. So here's just an example of what the output should look like. Now, usually trunking issues are misconfigurations, and probably because of native VLAN mismatches, trunk mode mismatches, or which VLANs across the trunk. So just paying attention to, did we change security on one, not on the other? Didn't have the right VLANs on the trunk? Just keep in mind, when you got a native VLAN misses, it definitely could give you security risks. Mismatches, lose connectivity. Allowed. I could have unexpected data or data I didn't expect to come through. So just keep that stuff in mind. So here you got an example import mode. I got allowed native 99. But the question is, what's on switch 3? Switch 3 says, hey, it's enabled, but I can't connect to the web server. Why? Because I don't have the appropriate, because I've got allowed VLAN native 99. So here you got an incorrect VLAN. You got 10 and 99. You're on 20. Guess what? I can't. I'm on 20. I'm not going to be able to get through switch 1 because that doesn't allow number 20 to go through. So just keep in mind, you want to make sure your VLAN must be allowed in the trunk before the frames are transmitted. Use the switch port trunk allowed command to verify what works. Show interfaces to make sure each interface is correct. Now the question then becomes is how do I got inter-VLAN routing and now I'm going to use a router. And basically here we got what is inter-VLAN routing. Well, I got layer 2 switches can't forward traffic between VLANs without what? Without the router. So I can go, so I'm sending something to between switches. I can go VLAN 10 to VLAN 10, but I can't go VLAN 10 to VLAN 30 without the presence of the router. All right, so I think we got back to cover this. So that's what inter-VLAN is. Now, in the past, all routers were used to route data between VLAN. You had to have a totally separate router interface. You had to specify, you basically had to say all packets would arrive to that one interface. They'd all go and leave at the same time. So it all got really confusing. Because the routing interface is connected to VLAN, it had to have a special VLAN between every device, and it's large networks, the number that required too many router interfaces just begot, just terrible. So here's just an example. The router is configured with 2 separate physical interfaces. So I've got, gigabyte 00 and 01. So I had to waste an IP address, 2 IP addresses just for the connectivity back to my switch network, which then says now I got to add tons of interfaces. Look at the school with 40, 50 switches, and if I had to do this to buy a router that had that many interfaces, ouch, pretty pricey. So they can come up with a system they call router on a stick, inter-VLAN routing. Now this basically uses one router physical interface. One of the router's physical interfaces are configured as the 802.1q trunk port. So what? This protocol now allows me to understand VLAN tags. So now I've got a port on a switch that understands inter-VLAN communication. Now I create what they call logical interfaces are created. And there's one sub interfaces per VLAN. So before we had to have 2 physical ports set up aside. Now I'm going to have 1 physical and 2 logical, and then each one of these sub interfaces are configured with an IP address to make sure it's in the same network. And then all the VLAN members are also configured to make sure they use that same sub interface on that default gateway. So here you've got, IP addresses, and you got G00.10. So this might VLAN 10, VLAN 20, VLAN 30. So that you've created these sub interfaces on the VLAN 1 for each one. So it's configured to operate as a trunk link connected to a switch port, a trunk switch port, and it allows that inter-VLAN trunking. So but you got to make sure the sub interfaces, because I got to match these VLANs now. So here's just activity that you can end up going through. I'll let you guys go through this. But now, how do I configure inter-VLAN? So one, I got to make sure that inter-VLAN routing requires routers. I got to have multiple physical interfaces, otherwise it ain't going to work. Physical interfaces need to be connected to a unique VLAN. Each interface has to have an IP address subnet for that particular VLAN, and of course, the network devices need to have the sub interfaces. So let's look at how to configure this. So you got IP address, you got your router, you get IP000. I brought it up, gave it an IP address. Here's my second interface. So I've got two physical interfaces up and running on this. Now, right now you go, it's just up. It just looks like we've assigned IP addresses to that. No big deal. Now, here you've got, let's just make sure I got this right. Switch configuration. Yeah, okay. I think they gave me the same. That's the router configuration. They goofed on that one. That's all right. We'll make it work. But what you want to do is making sure that you get your sub interfaces, single physical interface, must be connected to a trunk link, must be unique for each VLAN, and each sub interface is assigned to an IP address that's in the same subnet. So here you've created the switch configuration. You make sure the VLAN's correct, connected. So I've created my two VLANs. VLAN 10, VLAN 10, VLAN 30. You notice I didn't have to tell you. You could have done VLAN and return. It would have got you in VLAN editing mode. But here I created VLAN 10, got in VLAN port, did this. I assigned which interfaces it goes, and I also assigned the trunk. So it says, hey, for switch 1, I've defined F05 to be a trunk port. And that's pretty much all I've done there. Now, on the router side, what I have to do, now I've got to say, because I did here, I got, VLAN 10 and VLAN 30. So now for that trunk interface, I did, instead of like interface G00, give an IP address, well, guess what? I did G interface. This dot says now I'm creating a sub interface, and it's good common protocol to match the VLANs. Technically, I don't think you have to, but I think it's just so you understand what you're looking at as you're looking at reports. We did VLAN 10, VLAN 20, so I did that G0 interface. Whoops. Gave it a .10. Told it which encapsulation. I got to tell it that I'm now using .1Q and the VLAN. Give it an IP address and a subnet mask. The same thing, set up the second port. And then bring that interface up. So now if I show VLANs on the router, it tells you which encapsulations used. This is the key, which interface it's on, which VLAN it is, so it gives you a lot of information. Here you're seeing you got VLAN 30, VLAN 10, so it allows you. Now, if you do the verifying the sub-interfaces, you can do it a show IP route, and you can actually see which VLANs on the sub-interfaces. So how do I check verify routing? Trusty VLAN, trusty ping command. So it should do, or you can do a trace route. Both of these we're very familiar with how to configure that. So a lot of information about VLANs. So you might want to pay some time with it, and I think it'll do fine. If you have any questions, give me a call, send me a text, stop by my office.